Welcome to the DIY Honda Garage channel. DTC P0976 refers to an electrical issue within the shift solenoid valve B circuit in the 2008 to 2012 Honda Accord. This diagnostic trouble code, DTC, is triggered by an electrical circuitry malfunction rather than any mechanical faults in the transmission. The shift solenoid valve B is a crucial component within the vehicle's automatic transmission system. It controls fluid flow, enabling the transmission to shift gears smoothly. This component is generally found within the transmission assembly, and its failure can cause shifting issues. You'll typically find the solenoid labeled inside the transmission harness, and problems with this circuit can lead to delayed or erratic shifting. Therefore, it's essential to address this DTC promptly to ensure optimal transmission performance and vehicle drivability. The error described by DTC P0976 is related to a fault in the electrical circuit of the shift solenoid valve B. The shift solenoid valve is responsible for controlling transmission fluid flow, thereby enabling gear changes necessary for efficient vehicle operation. This solenoid is directly integrated within the transmission system, typically situated in the valve body. It receives signals from the powertrain control module, PCM, to engage or disengage, thereby influencing the vehicle's ability to shift gears properly. Electrical issues such as shorts in the wires or poor connections can contribute to this fault, but mechanical problems are ruled out in this case. Understanding its location and function is crucial when diagnosing the issue effectively. The possible causes for the P0976 code largely revolve around electrical faults. First, a short circuit in the wiring could disrupt the signal reaching or from the shift solenoid, triggering the DTC. Secondly, the shift solenoid B may be defective itself, leading to a malfunction and therefore causing the issue. Lastly, problems with the powertrain control module, PCM, which interprets signals and relays commands to the solenoid, can also cause this fault. It is important to methodically check each of these potential causes during the troubleshooting process to narrow down the root of the problem. Each of these elements plays a critical role in the operation of the transmission and requires careful evaluation. Symptoms manifesting from DTC P0976 typically involve problems related to the vehicle's transmission performance. Drivers may notice delayed shifting, where the transmission hesitates before moving to the next gear. Erratic gear changes are also common. The transmission may shift unpredictably or fail to engage properly, resulting in poor engine performance. Additionally, there might be instances where the transmission does not engage at all, preventing the vehicle from moving. Awareness of these symptoms is vital for drivers and technicians alike, as they provide critical clues about the health of the transmission system. Understanding these warning signs can facilitate timely and effective repairs, thereby maintaining vehicle operation. The first step in troubleshooting the P0976 DTC is to turn the ignition switch to the on position, also referred to as on 2, which powers the vehicle's electrical systems without starting the engine. Before diving into diagnostics, it is crucial to record all freeze frame data and onboard snapshots using the Honda Diagnostic System, HDS. This allows technicians to capture a moment of the vehicle's operational parameters at the time the DTC was triggered, providing valuable context for the diagnosis. Following this, one should also review the general troubleshooting information available for the system. This practice establishes a foundation for understanding potential issues affecting the electrical circuitry, ensuring a thorough approach throughout the diagnostic process. In this step, you will clear the DTC using the Honda Diagnostic System. This action resets the vehicle's onboard diagnostic system, and clears the previously stored fault codes. Next, start the engine while it is in the park position, which is necessary to ensure the system operates under the least load conditions. After starting, it is essential to wait for at least 1 second to allow the system to stabilize. This pause will enable the onboard diagnostic trouble code DTC monitoring to begin afresh from a cleared state, which is vital for detecting any reoccurrence of the error. This approach is integral for isolating persistent problems from transient issues that may not necessarily warrant a deeper investigation. After starting the engine and allowing the system to stabilize, the next step is to check for pending or confirmed DTCs using the Honda diagnostic system. This step acts as a verification process to determine if the P0976 code reappears. If the HDS indicates that DTC P0976 is flagged as a pending or confirmed error, it necessitates further investigation into the circuit related to the shift solenoid valve B. Confirmed DTCs are those that have been consistently detected, while pending codes are temporary and may not require immediate action. Understanding this classification helps technicians distinguish between persistent and intermittent problems effectively. Once you have established the presence or absence of DTC P0976 in the system, you must proceed accordingly. If the HDS indicates that the code is present, you will move on to Step 8 for further investigation into the electrical circuit. On the other hand, if no DTCs are indicated, it is necessary to proceed to Step 5 to test the functionality of the shift solenoid valve B through additional tests using the HDS. This step is critical as it enables technicians to narrow down whether the fault resides within the solenoid itself or lies elsewhere in the circuit, ensuring a systematic approach to troubleshooting. In this step, you should select the Shift Solenoid Valve B test option from the Miscellaneous Test menu on the HDS. This specific test allows you to activate the solenoid and check its operational status. You should listen for a clicking sound, which indicates that the solenoid is functioning correctly and activating as designed. If a clicking sound is audible, it signifies that the solenoid is receiving power and electromechanical components are operating appropriately. Conversely, if no sound is heard, it suggests a problem, likely an electrical fault, preventing the solenoid from activating, and necessitates progression to Step 8 for further diagnostics. After confirming the functionality of Shift Solenoid Valve B, proceed by restarting the engine while it is still in park. Again, you need to allow at least 1 second for the system to go through its startup processes and begin monitoring for any potential DTCs immediately. The next action is to monitor the onboard diagnostic OBD status utilizing the HDS within the DTCs menu. This status provides real-time updates on the operation of the system and helps determine whether DTC P0976 is still present. If the HDS indicates that the status for P0976 is a failure, this confirms that the issue persists and further steps are required for resolution. At this stage, you should review the HDS output to assess the diagnostic status of DTC P0976. If the HDS indicates a failed status, this validates that the electrical circuit problem remains unresolved, and you'll move on to Step 8 for further analysis. However, if the HDS reflects a past status, meaning there is no current fault detected, it leaves the possibility of an intermittent failure. Therefore, you should then check for a possible short to body ground in the wiring between the shift solenoid valve B and the PCM. This could involve inspecting the wiring harness for any signs of wear, fraying, or disconnections that could indicate a fault in the electrical circuit. In this troubleshooting phase, the first action is to turn the ignition switch to the lock position, which ensures all electrical systems are powered down. Next, you will jump the SCS line using the HDS, an action that signals the diagnostic tool to enter a special service mode. This procedure typically involves connecting the HDS to the appropriate terminal to facilitate proper diagnostics. After completing this procedure, prepare for further diagnostics by disconnecting the PCM connector C, denoted as 49P, which houses multiple terminals responsible for communication between the PCM and various components of the vehicle. Ensuring you're ready with the right tools and understanding of the connector layout is essential for the subsequent measurements. In this step, you will focus on the PCM connector, specifically connector C, referred to as the 49P connector because of the number of pins it contains. Disconnect this connector to access the internal terminals. Using a multimeter, you will measure the electrical resistance between terminal C28 of the PCM and body ground. This is important to ascertain whether the resistance is within acceptable limits, specifically less than 12 ohms. A resistance reading higher than this threshold may indicate a fault in the wiring or a poor connection that could be contributing to the DTC P0976. Understanding these readings is vital for determining the health of the electrical circuit, influencing the effectiveness of the troubleshooting process. Evaluate the resistance measurement obtained in the previous step. If the resistance is less than 12 ohms, this is a positive sign that indicates a well-functioning circuit between terminal C28 of the PCM and body ground, allowing you to proceed to step 12 for continued testing. On the other hand, if the resistance exceeds the 12 ohm limit, it signifies a problem within the wiring itself. This could lead to either a poor connection, a break in the wire, or other faults that would impede proper electrical flow, necessitating additional troubleshooting of the wiring harness. Identifying resistance levels is crucial for diagnosing the health of the electrical components involved in the shift solenoid circuit. The final step in this troubleshooting series requires you to disconnect the shift solenoid wire harness connector. This disconnection allows for further testing and eliminates any potential interference from other circuits during diagnostics. With the connector removed, you can conduct more targeted tests on the shift solenoid itself to determine if it is indeed the source of the problem. This could include checking for voltage at the connector or testing the solenoid resistance directly. Each aspect of this diagnostic process is crucial to determining the root cause of DTC P0976 and ensuring the shift solenoid valve B operates effectively within the transmission system. Once repairs have been performed following the diagnostics for DTC P0976, it's essential to verify that the issues have been resolved appropriately. Begin by checking the diagnostic trouble codes stored in the vehicle system to ensure that P0976 no longer appears. Following this, conduct a comprehensive road test of the vehicle to observe its shifting behavior under various driving conditions. This test is crucial for confirming that the transmission is operating smoothly without any symptoms of delay or erratic changes. Additionally, confirming proper operation will provide assurance that the repair was successful and the vehicle is now ready for safe use. Preventive maintenance is key to avoiding future occurrences of DTC P0976. Regular diagnostic checks can help catch issues before they escalate into larger problems, providing peace of mind regarding your vehicle's performance. Inspecting the wiring harness routinely for wear and tear, corrosion, or loose connectors can significantly reduce the risk of electrical failures. Additionally, monitoring the functionality of the shift solenoid can help ensure that it continues to work properly as it ages. Being proactive with these inspections and checks can lead to a more reliable transmission system and longer vehicle lifespan, ultimately enhancing both performance and safety. In conclusion, DTC P0976 highlights an electrical issue within the shift solenoid valve B circuit of the 2008 to 2012 Honda Accord. Understanding the crucial role this solenoid plays in the functioning of the transmission can aid technicians in diagnosing problems more effectively. Thorough and methodical troubleshooting is essential to identify the root cause of the issue, whether it be an electrical short, faulty solenoid, or PCM-related problems. Following the outlined steps ensures that any electrical faults are comprehensively assessed and addressed, preventing further complications. By being vigilant with diagnostic checks and preventive maintenance, vehicle operability can be significantly optimized, ensuring safe and reliable transportation. Please like and subscribe to the channel. See you next time.